Hello everyone, my name is Muskan and today I'm going to be presenting on the topic cosets and Lagrange theorems. Coset and Lagrange theorem are fundamental concepts in abstract algebra that provide valuable insights into the structure of groups. This presentation will guide you through the definitions, properties, and applications of these important ideas, equipping you with the knowledge to tackle more advanced group theory challenges. Definition of cosets. Left cosets, right cosets, and their relationship. Left cosets. Given a group G and subgroup H, the left coset of an element G in G with respect to H is the set of all elements in G that can be obtained by multiplying G and any element in capital H. Mathematically, the left coset of G with respect to H is denoted by GH and defined as GH is equals to GH H in capital H. Right cosets. Similarly, in right cosets of element G in capital G with respect to H is the set of all elements in G that can be obtained by multiplying any element in H and G. The right coset of G with respect to capital H is denoted as HG and defined as HG equals to HG H in G, H in H. Relationship. While left and right cosets are distinct concepts, they are closely related. In general, left and right cosets of the same element may not be equal, but they are always have the same size. Let's see some properties of cosets. Partition of the group. The left or right coset of a subgroup H in a group G form a partition of the group G, meaning they are disjoint sets that cover the entire group. Coset equality. Two left or right cosets are equal if and only if they contain the same elements. In other words, GH is equals to G dash H if and only if G and G dash belong to the same left coset. Coset size. The size of a left or right coset is always equal to the size of the subgroup H, regardless of the choice of the representative element G. Closure under coset multiplication. The product of two left or right cosets is again a left or right coset. This property is crucial for understanding coset multiplication and its application. Index of a subgroup. Definition. The index of a subgroup H in a group G, denoted as G is to H, is the number of distinct left or right cosets of H in G. This represents the number of copies of the subgroup H that are contained within the group G. Significance. The index of a subgroup is an important concept in a group theory as it provides information about the structure and organization of the group. It is a fundamental tool for understanding the relationship between a group and its subgroup. Calculation. The index of a subgroup H is a group G can be calculated by dividing the order or size of the group G by the order of subgroup H, as long as the group G is finite. Let's see Lagrange theorem. Statement. Lagrange theorem states that for any finite group G and any subgroup H of G, the order of H divides the order of G. In other words, the size of a subgroup H is a factor of the size of the group G. Corollary. As a corollary, the index G is to H of a subgroup H is a finite group G is equal to the ratio of the order of G to the order of H. Significance. Lagrange's theorem is a fundamental result in group theory that provides a powerful tool for understanding the structure and properties of finite groups and their subgroups. Applications. This theorem has numerous applications in various areas of mathematics, including number theory, abstract algebra, and beyond. Proof of Lagrange's theorem. Partition by cosets. The proof of Lagrange's theorem begins by considering the left or right coset of a subgroup H in the group G. As mentioned earlier, these cosets form a partition of the group G. Counting cosets, the number of distinct left or right coset of H in G is precisely the index G's to H. This is a crucial step in the proof as it establishes the relationship between the order of G and the order of H. Counting group elements. Since the cosets form a partition of G, the total number of elements in G is equal to the sum of numbers of elements in each coset. This leads to a final conclusion that the order of H divides the order of G. Coset multiplication. Definition. The product of two left coset GH and G' H is defined as the left coset GG' into H, where G and G' are elements in the group G. Similarly, the product of two right cosets HG and HG' is the right coset HG'. Closure. As mentioned earlier, the closure property of cosets ensure that the product of two left or right cosets is again a left or right coset. This property is crucial for understanding the behavior of cosets under multiplication. Applications. Coset multiplication has important applications in group theory, such as in the study of factor groups and the construction of quotient groups. It also plays a role in the classification and analysis of finite groups. Coset decomposition. Representation. Any element in group G can be uniquely represented as the product of an element in a subgroup H, an element from corresponding left or right coset. This is known as coset decomposition of group G with respect to the subgroup H. Significance. Coset decomposition is a powerful tool in group theory as it allows us to understand the structure of a group in terms of its subgroup and cosets. It provides a way to systematically analyze and work with groups by decomposing them into simpler, more manageable components. Applications. Coset decomposition has numerous applications such as in the study of factor groups, the construction of quotient groups, and the analysis of group homomorphisms and isomorphisms. Common misconceptions. Coset equality. One common misconception is that left and right cosets are always equal. As mentioned earlier, while left and right cosets have the same size, they may not be equal in general. Lagrange's theorem and finite group. Another misconception is that Lagrange's theorem applies to all groups, including infinite groups. However, Lagrange's theorem is only valid for finite groups, as the order of infinite groups may not be defined in the same way. Coset multiplication and commutativity. Some people mistakenly believe that coset multiplication is commutative, but this is not the case in general. The order of the factors in coset multiplication is important and can affect the resulting coset. Cosets and subgroup normality. Finally, a common misconception is that the left and right cosets of a subgroup are always equal if and only if the subgroup is normal. This is not necessarily true, as the equality of left and right cosets depends on the specific properties of the group and subgroup, not just the normality of the subgroup. Applications and examples. Group theory. Cosets and Lagrange's theorems are fundamental concepts in group theory, with applications in the study of factor groups, quotient groups, and classification of finite groups. Number theory. These ideas also have important applications in number theories, such as in the study of modular arithmetic, congruence, and the structure of finite abelian groups. Abstract algebra. Cosets and Lagrange's theorems are essential tools in abstract algebra, providing insights into the structure and properties of various algebraic structures, including groups, rings, and modules. Combinatorics. Coset decomposition and the index of subgroups have applications in combinatories, where they can be used to count and analyze certain types of structures such as partitions and permutations. Thank you.